All right. Let's dive into this mountain of Android UI design stuff you've given us. You're trying to become like a UI master, huh?
Yeah.
Well, we're here to give you the tools to make those interfaces not just functional, but actually enjoyable to use.
Yeah, I think the coolest part about Android UI design is just how much it's changed over the years. We started with those basic layouts, and now we have these crazy dynamic and responsive interfaces that you see in all the top apps. And we're gonna break down those core pieces for you today.
Perfect. First things first, we got to talk about fragments. They just keep popping up in your research. And honestly, I'm still a little iffy on how they work. They're like, what, like mini activities?
Yeah, that's a good place to start. Okay, so imagine you're building an app for both phones and tablets, right? Phones have limited screen real estate, so you usually show one view at a time. But on a tablet, you got all that extra space for multiple panels, like, side by side. So fragments, they let you create these different layouts and then adapt to the screen size smoothly.
So that's how, like, some news apps have those cool multi-pane layouts where you can browse headlines and read an article, like, all at the same time.
Exactly. It's all about making things smoother, more fluid, for the user. I remember when I was working on this travel app and we wanted to show, a map next to a list of destinations. Man, fragments were like a lifesaver for that. It would have been a nightmare trying to handle that with just activities.
Okay, yeah, that's much clearer. It's kind of like those Lego blocks where you can build different things using the same pieces.
Yeah.
Like the fragments are those blocks, and then the activity is the base plate, the thing they snap onto.
Perfect analogy. And because they're modular, you can reuse those fragment blocks in different parts of your app. It makes your code so much more efficient.
Nice. Now, another UI piece I'm curious about is menus. They seem so simple at first glance, but the more I dig into your research, the more I see just how much is going on behind the scenes.
Right. You've got your typical options menu inside an activity, but then you've also got those contextual menus that pop up when a user does a long press on something. And then on top of that, you got pop-up menus for even more choices. And the cool part is that they aren't just static lists.
Wait, really? What do you mean?
Think about it. Say you're building a music app. You might have a menu option that says add to playlist. But that only makes sense if a song is actually playing, right? Well, you can actually tweak the menu while the app is running, adding or removing items based on what the user's doing.
Wow, that's pretty smart. It makes the app feel way more responsive. So how do you actually set up those dynamic menus? Is it tricky?
Not as bad as you might think. You define your menus in resource files, just like you do with your layouts. Then in your code, you use what's called the menu item interface to control how they work. It's all about linking the look of the menu to the code that makes it interactive.
Okay, got it. All right, next stop on our UI tour, containers. Now, I got to admit, when I first saw that term, I was like, how exciting can containers be? But they're pretty important to the whole layout process, right?
Absolutely. Think of them as the invisible scaffolding holding everything together. Without containers, your buttons, text fields, images, they'd all just be floating around in chaos. Containers provide the structure and the organization for all those visual pieces.
So, like, if we have a list of, I don't know, let's say items, a container tells the app how to, like, arrange them.
Exactly. And there are a bunch of different types of containers, each one with its own strengths. You got linear layout, where items are arranged, in a single line, either horizontal or vertical. Then there's table layout, which pretty self-explanatory, arranges things in rows and columns just like a spreadsheet.
Okay, I get it. So it's like picking the right shelf for your books. You wouldn't put a cookbook on the same shelf as a thriller, right?
Yeah.
Each container has its purpose.
I like that. And as you get more comfortable with layout design, you can even start mixing different containers together to create more complex stuff. It's kind of like a puzzle, figuring out how all the pieces fit together.
But what if we need something more flexible than just a simple list or table? Like, what if you want to position stuff relative to each other?
Good question. That's where relative layout comes in. It lets you define the position of something in relation to another element or to the parent container. Like you can say, put this button to the right of that image or align this text to the bottom of the screen. Gives you a lot of control.
Nice. So if I wanted a button to always stick in the bottom right corner, no matter what else is on the screen, I could do that with relative layout.
Exactly. And there's also constraint layout. It's a newer container that gives you even more flexibility and power, but we'll get into that a little bit later. For now, let's move on to the things users actually see and get to play with, the visual controls.
Okay, now we're talking. This is where it gets fun, right? We got buttons, text fields, images, all the pieces that make an app come to life.
Right, and just like there are tons of ways to express yourself with words, Android gives you a whole variety of visual controls to get information across and create those cool interactions.
So walk me through some of the basics. Like, what are the building blocks of this visual language?
Well, you got your trusty text view for just showing text, static text. Think of it like the label on a bottle. Tells you what's inside. Then you got edit text. This one lets users input text, like when they're filling out a form.
So text views for showing info, and edit text is for getting info from the user.
Got it. What about those interactive elements, the things you can click and tap?
Well, of course, you got buttons. Those are key for triggering actions. And then you have radio buttons and checkboxes for selecting options. I imagine you're designing a settings screen for your app. You'd probably use a bunch of these to let users, customize their preferences. Oh, okay, that makes sense. And what about the elements that give feedback to the user, things like progress bars?
Oh yeah, progress bars are super important, especially if something takes a while. They let the user know something's actually happening. Think about downloading a large file, That progress bar reassures the user that things are moving along. And then you've got seek bar, which lets users select a value within a range, like adjusting the volume or screen brightness.
Wow, there are so many different controls to choose from. It's like having this giant toolbox at our disposal.
Yeah.
But how do we know which one to use for a specific task?
That's where understanding the purpose and behavior of each control is super important. It's about picking the right tool for the job. And what's really neat is that each control comes with a bunch of attributes you can tweak.
Really? Like what?
Let's take edit text as an example. You can use this attribute called input type to tell it what kind of keyboard to show. So if you're asking for a phone number, you can display a numeric keypad. Makes things a lot easier for the user.
That's pretty clever. So it's not just about picking the right control. It's about fine-tuning it to fit, the specific needs of your app. But I have a feeling things are going to get even more interesting, right? We've talked about simple controls, but what about those more complex elements that really take an app to the next level?
You're right. We've just scratched the surface. Things get really cool when we start talking about complex controls like list views, grid views, and expandable list views. These are the workhorses behind so many apps. They let you display and interact with data in all sorts of dynamic ways. But we'll save that for part 2 of our deep dive.
Welcome back. So I'm really excited to dig into those complex controls we kind of touched on earlier. They're really the backbone of so many of those dynamic and data-driven Android apps that you see everywhere these days.
Yeah, for sure. We talked about fragments being like Lego blocks, but complex controls sound like we're like building some serious structures. Yeah, that's a great way to think about it. Let's start with list views. So imagine you're building a music app and you need to show a playlist, right? And it could have, hundreds of songs. Well, a list view lets you present all that data in a scrollable list, making it easy for the user to look through and interact with each item.
Okay, yeah, I get that. But I'm picturing a static list. How do you deal with situations where the data is always changing, like a news feed or a social media app?
That's where it gets really interesting. We use something called an adapter to kind of bridge the gap between our data and the UI. It takes your raw data, whatever format it's in, and transforms it into something that the list view can understand and display.
So the adapter is like a translator, right? It converts the language of data into the language of the UI.
Exactly. And there are different types of adapters depending on, what you need. You might use an array adapter for simple lists of text, or a simple cursor adapter for data from a database. Or you can even, make your own custom adapter for unique situations.
Oh, you mentioned custom adapters. That sounds pretty powerful, but also kind of intimidating.
Yeah.
Can you give me an example of when I might need to create one?
Yeah, absolutely. Let's say you're building a chat app, and each message needs to show a profile picture, a username, a timestamp, and then the message itself. A custom adapter gives you that really fine-grained control over how each of those elements is displayed within the list view, which helps you make sure the design is polished and user-friendly.
Okay, yeah. Now that makes sense. It's
Yeah.
it's like having a tailor-made outfit instead of something off the rack.
Yeah.
You get a perfect fit for your specific data.
Exactly. And once you get, the hang of adapters, it opens up a whole world of possibilities. You can use them with other complex controls like grid views and expandable list views too.
Okay, cool. Let's talk about those. I'm guessing grid views are what we see in like image galleries and app stores, right?
You got it. Grid views arrange items in a grid format, which is, perfect for visually presenting stuff like photos, products, app icons. And just like with list views, you can use adapters to fill the grid view with data from different sources.
Now, expandable list views, those sound interesting. What are those all about?
So imagine you're building an email app
Yeah.
and you want to group emails by sender. Expandable list views let you create those collapsible categories so that the user can, expand a category to see the individual emails inside. It's a great way to manage huge data sets and present information in a hierarchical way.
That's super helpful. So we have list views for linear lists, grid views for grids, and expandable list views for hierarchical data. It's like we have this whole like arsenal of tools for organizing and presenting information in our app. But let's go back to fragments for a second. We talked about them in part one, but how do they actually work with these complex controls?
Great question. So you can actually put a complex control right inside a fragment's layout. For example, you could have a fragment that has a list view to display a list of items.
So it's like nesting those Lego blocks. A fragment can contain a complex control, which then contains our data all neatly organized and presented to the user.
Yeah, exactly. And remember, fragments themselves can be nested within activities or even other fragments. This lets you create some super flexible and dynamic UI designs. Think about a navigation drawer. That could be a fragment. And then inside the main content area, you might have another fragment with a list view to show, a list of items. It's all about creating those layers and hierarchies to structure your app's UI in a smart way.
Yeah, it's really starting to click for me now. But hold on. You mentioned earlier that constraint layout is a more advanced container than relative layout. Can we unpack that a little bit?
Of course. Remember how relative layout lets you position stuff, relative to each other? Constraint layout takes that idea and like supercharges it. It gives you this really powerful visual editor where you can define constraints between elements. You can control their size, their position, their alignment, all with incredible precision.
So it's like a more visual and intuitive way to build layouts.
Exactly. Constraint layout gives you a drag and drop interface where you can create these relationships between elements using guidelines, barriers, chains, all sorts of things. And it also has advanced features like bias and ratios for fine-tuning the positioning and sizing of your UI pieces.
That sounds really powerful, but maybe a little overwhelming. What kind of situations is constraint layout best suited for?
It really shines when you're working with those complicated layouts that need to adapt to different screen sizes and orientations. Imagine you have a layout with a bunch of buttons, text fields, images, and they all need to be perfectly aligned and spaced, and this has to work across all kinds of different devices. Constraint layout's flexibility makes handling those situations a lot easier.
Okay, yeah, constraint layout is officially on my list of things to check out. It sounds like a game changer for complex layouts. But before we wrap up part two, can we circle back to those dynamic menus? We talked about how they can change based on what the user's doing, but can we get a little more specific about how that works in code?
Yeah, totally. So you can use this method called onPrepareOptions menu inside your activity to dynamically add, remove, or modify menu items. This method gets called every time the menu is about to be displayed. So you can tailor the menu options based on the current state of your app.
So like, for example, if the user's logged in, we could show a logout option, but if they're not logged in, that option wouldn't show up.
Exactly. And you can get even more specific. You can use those methods like set visible, set enabled, and set title on individual menu items to control whether they're visible, whether they can be interacted with, and even the text that's displayed.
Wow, it's amazing how much control we have over the user experience.
Right.
by combining these techniques with fragments, containers, visual and complex controls, we can build some really, really sophisticated and intuitive interfaces. But I'm curious, what are some of the common mistakes or challenges that developers run into when they're working with these UI elements?
That's a great question, and that leads us perfectly into part 3, where we'll dive into some common UI design challenges, performance considerations, and those all important accessibility guidelines. We'll give you the knowledge and strategies to avoid those common pitfalls and build Android UIs that are not just visually appealing but also robust, efficient, and inclusive.
Welcome back for the last part of our deep dive. We've covered a lot of ground, from fragments to those complex controls. But there's one super important aspect we need to talk about: accessibility.
Yeah.
Something I'm really passionate about, because a truly great UI is one that everyone can enjoy, right?
You're absolutely right. Accessibility is often overlooked, but it's really essential for creating apps that are inclusive. It's about understanding that users interact with our apps in all sorts of different ways. Some people might have visual impairments, others might have trouble using touch screens. Our job as developers is to make sure our apps are usable by as many people as possible.
Okay, yeah, I get that. But where do we even start? What are some of the key things to keep in mind when we're designing for accessibility?
Well, one fundamental principle is to provide alternative input methods. For example, not everyone can use a touchscreen, so we need to make sure our apps are fully navigable using a keyboard or even voice commands. Android has these built-in accessibility services like TalkBack. It's a screen reader that reads the content of the screen out loud for users who are visually impaired.
TalkBack, that sounds amazing. It's like having a narrator, guide you through the app. But how do we make sure that our app plays nicely with these accessibility services?
That's where content descriptions come in. We need to provide meaningful descriptions for all our UI elements so that TalkBack can accurately tell the user what their purpose is. For instance, if you have a button that just says, okay, that doesn't really tell a visually impaired user what the button actually does. We need to be more descriptive, like submit order or close window.
So it's not just about the visual label on the button. It's about providing that extra layer of information for users who might not be able to see it.
Exactly. And it's not just about screen readers either. Clear content descriptions benefit everyone, even users without disabilities. They make your app easier to understand and navigate.
Yes, that's a great point. It's kind of like those signs you see with both text and pictograms. Yeah. It makes it clear to everyone what the sign is trying to say.
Another important thing to think about is color contrast. For users with low vision, it's so important to have enough contrast between text and background colors. We don't want text to just blend in and become impossible to read.
Right. Like avoid using light gray text on a white background. Ouch. My eyes.
Exactly. And thankfully, Android provides, tools and guidelines to help us choose color combinations that meet accessibility standards.
Speaking of tools, is there anything out there that can help us test our apps for accessibility?
There is. Android Studio has this really fantastic tool called Accessibility Scanner. It analyzes your app's UI and points out potential issues. It can detect things like missing content descriptions, insufficient color contrast, and other common mistakes.
Accessibility Scanner. That sounds like a must-have for any Android developer. It's like having a second pair of eyes that are specifically looking for accessibility problems.
Absolutely. It's a great way to catch those oversights, early on in the development process. But remember, accessibility isn't just about technical checks. It's about empathy. It's about putting yourself in the shoes of users with different abilities and making sure our apps are truly inclusive and enjoyable for everyone.
Well said. It's been a really incredible journey exploring the world of Android UI design. We've covered so much, and I'm honestly feeling pretty inspired to apply all these new insights to my own projects.
Me too. What stands out to you the most from our deep dive?
Honestly, it's the power of these tools and techniques to not just build UIs that are visually appealing, but to create experiences that are truly accessible and user friendly for everyone. It's about going beyond just aesthetics and thinking about the diverse needs of our users.
I couldn't have said it better myself. That's the heart of great UI design. Now, for those of you listening, we'd love to hear your thoughts. What are you most excited to try out in your Android projects? What challenges do you anticipate? Share your experiences and connect with us on social media. And remember, the quest for building those amazing UIs, it's an ongoing journey. Keep exploring, keep experimenting, and never stop learning.